and you will do a Friedel-Crafts acylation reaction by using acetyl chloride and aluminum chloride as a Lewis acid catalyst. This will get acylated, and you will figure out what this is, what's the structure of this, and using that, your job is to tell me what was the original aromatic compound given to you. Does that make sense? So once again, your goal in this is not just to do Friedel-Crafts acylation. Of course, we are doing that, but your goal is to identify the unknown aromatic compound reactant by figuring out the acylated product and then deciding what this is. Does that make sense, everyone? Yeah? So please make sure if that's not the goal you've written, you should change it because your goal should reflect what we actually do. Okay, mechanism. By the way, does anybody know what this means? Because I don't know if I've seen this representation before.
It has an R group on it.
Say that one more time.
It has an R group on it.
And what does it mean to stop the bond from the center of benzene?
R can be anywhere.
Exactly. That's really what this is. It's a very general representation saying this bond, obviously it can't be in the center, but this bond can be on any of those points. Now, we don't have, there's a list of possible compounds given to you in the book, right?
Yes.
We don't have all of them. Let me speak on 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. The possible compounds are follows. These are the only ones that I am able to give to you. So, it could be anisole, or orthoxylene, or metaxylene. Look up the structures, please. Paraxylene, or toluene, or what did I miss? Mesitylene, or ethylbenzene. These are the only possible compounds of benzene that the unknown can be. Here are your assignments. Ready? Everybody? By the way, the numbers I'm going to give to you has nothing to do with the order in which those are written. Let's start with Han. Why don't you start with 1? Make sure you're writing this somewhere. Unknown number. That should go on your data table. Your data table on the top is the best place to say unknown number whatever. So unknown number 1, unknown number 2. Is he have 1? I'm just trying to see how he's labeled them. Sorry. Okay. Han is number 1, Camilla 2, Mar 3, Carter 4, who's next? Ali 5, 6,
Sweet.
and 7, and 1, and 2, and 3, and 4, and 5, and 6. Sounds okay, everybody? Oh, 7, and pick one number between 1 and 7. What's your favorite? 4. Perfect, that's yours. The point is, please make sure you write the number on top of the data table. Okay. Now I'll walk you through the setup, the glassware setup in just a minute. But as far as the procedure is concerned, I was reading through the procedure. So far everything is okay. It's pretty familiar to you. And as I said, we'll go over this, the whole glassware thing in a second. But there was a point where it said to use an automatic pipette or a calibrated pipette to measure out 0.5 milliliter of the aromatic compound. Am I right?
Yeah.
Now, I think the best thing to do for that step is to maybe calibrate a Pasteur pipette for half mil. You guys have a conical vial, probably the smaller one. What is it, 3 mil? Yeah, I think so.
So not the syringe.
No, for that one. Oh, you and I talked about the syringe. Ah, that's an interest. Okay, hold on. Okay, calm down, Sunita. Slow down. Because then you need to use the syringe to add to your experiment. Am I right? Mm-hmm. Ooh. You know what? Then yeah. Sorry. Can I scratch what I just said? disregard what I just said. Let's just do a syringe. Yeah, let's just do a syringe. I'll get out a box of syringes. Let's just do syringe. That's probably going to be easier. Okay. There's also a point later on, once you've done the 30 minutes of mixing and all of that stuff, and now you're ready to isolate the product. At one point, it wants you to use 4 milliliters of ice cold water. Does that ring a bell?
Yes.
My suggestion is, make sure you set some DI water in a beaker in an ice bath way early, so that it's ice cold by the time you need it, so you don't have to wait. It really needs to be ice cold. So I would rather us not add ice cubes to it, because ice cubes is not DI water, right? Ice cubes is just made out of regular water. So maybe the better thing is take DI water in a beaker or something and just set it in an ice bath, but you have to do it way early, so that it's ice cold by the time you use it. Does that make sense, everybody? So please think about that ahead of time. And then of course you are doing extractions and blah blah blah. I just want to remind everybody, if you're going to extract out with the sodium bicarbonate, remember sodium bicarbonate is a weak base, but it reacts with strong acids, and one of the byproducts is
Carbon dioxide.
Carbon dioxide. And therefore, with experience, right? I mean, if there's a lot of acidity in the aqueous solution, you're going to get lots of bubbles, and then you can spill everything over. You got to be careful. You got to be slow there. And like last week, I was showing everybody this, that you've got the conical vial. Maybe not cap it all the way so you don't have too much pressure in there. Maybe you mix the layers by sucking the bottom layer, dumping it on the top, and doing that several times to mix the layers well, while still not having too much pressure to deal with. That's a step you guys have to be very, very careful. Does that make sense, everybody? We all good? Yes.
Are we doing the chromatography?
Yes, I'm getting to that. We're not there yet. But if, just going in order here. Everybody okay? Cool. And then of course, eventually, you're doing all of those steps, and then you're drying your organic layer with sodium sulfate. And then you get your organic layer, and then you're doing the column part. Isn't that right? Now guys, this lab is over 2 weeks. So we're going to do part of it this week, and then the rest we will do next week. So here's my suggestion. Once you have dried your organic layer, so let's say this is my organic layer, and I've got the drying agent, and I've got the organic, right? Everybody okay? Beautiful drawing, right?
Very good.
Castle's got nothing.
While this is drying, we are waiting. Let's get our column ready. Column is a really, we are doing a micro column, which is almost like a curve, so not complicated at all.
It's okay.
This one, what we are doing.
They're fine.
All we are doing is we are taking a pasture pipette. It's a pasture pipette. Taking a tiny piece of cotton, regular cotton over there, and using something, micro spatula might be a good thing to use here, and pushing the cotton all the way so it gets lodged right there. I find micro spatulas to be the best to do that way. And once you have done it, then you are filling in alumina. Alumina is aluminum oxide. Al2O3 is also known as alumina, just like silica. It's very powdery, grainy, like sand. And you're filling that in till about, I would say about, I know the book said 3 centimeters, but 3 centimeters is only about this much. Maybe 3 to 4 centimeters. Again, very approximately you're filling it here. It's like sand. You just get it in one of those weighing boats and pour it in, kind of thing. Okay? That's your column pretty much. Clamp it somewhere so it's standing upright the whole time. Now, this is ready. Get an Erlenmeyer flask, probably whichever size, doesn't matter. Weigh it, pre-weigh it, and that goes at the bottom. Make sure it's weighed, and that means it's clean and dry also. Okay, that goes under the column. So That's what that setup looks like. So hopefully by then this is dry. Now you're taking the organic portion, the organic layer from here, just the organic portion, and it gets poured, well, past your pipette, use a past your pipette. The organic layer gets transferred onto alumina. The purpose of the alumina column here is if the product has any color to it, alumina will absorb the color. Although column chromatography serves different purposes, but that's all we are doing here. So basically put your entire organic layer from the drying agent in there so that the liquid travels down. It's just like sand, right? I mean, the liquid's going to travel down, and drip down here. So we are collecting the organic portion. Does that make sense, everybody? Give me just 1 second, because otherwise I'll forget. I will strongly recommend, though, when you're doing this, do not forget to wash the drying agent with methylene chloride. Is it methylene chloride? Yeah, dichloromethane, right? Once you've transferred the organic layer, don't forget to wash your drying agent and also transfer it through here. Sounds okay, everybody?
Transfer the drying agent for there?
No, the liquid.
Oh, the
Liquid. Wash the drying agent and transfer the liquid in there. Once you have and all of that has dripped out, then please also one more time wash the alumina again at the end with, what does it say?
Methylene chloride.
Yeah, it's maybe
Dichloromethane.
another dichloromethane, whatever, it's the same thing. But yeah, whatever, 1 milliliter or so of methylene chloride. Just basically just pour that down in here so that if any product is stuck, you can wash that out. And everything is collected here. This is where we will stop. What was your question? Why do we need to have the color? We don't, the product is not colored. So the color is indicating impurities that we are trying to get trapped into.
But that's to take away the color, you said?
Yes,
Yeah.
which is indicating impurities.
So we will have a color.
The product should not have a color.
But
The
if we,
product should not be colored. The color should get stuck here.
oh, that's what, but over here we have a color.
Yeah, this may be colored,
Yeah.
but then the impurity gets, the colored impurity gets hot. Now, when we say color, guys, pale yellow is not called color for us because almost everything is pale yellow. But sometimes this could be a different color which is drastically different from pale yellow. So that's more of a purification purpose. Does that sound okay, everybody? So what I'm suggesting is, let's get through this whole part. Once you have all your organic stuff into that pre-made Erlenmeyer and you got the organic liquid in here, we will save this. How will we save this? The next step, please correct me if I'm wrong, is the next step from here to evaporate off methylene chloride?
Yes.
Okay,
Yes.
so we will let nature do that instead of us doing it. At this point, please label the flask with your name. Please label with your name. Write with a Sharpie on it or whatever, there are Sharpies right here. Cover it up with a small piece of aluminum foil. Cover it, cover the top with aluminum foil. You know where aluminum foil is. But punch a few holes in the aluminum foil, maybe 3, maybe 4 holes. Just punch a few holes, couple of holes in there, and that I will take from you at the end of the day, and I will probably store it. I need to get a container for us somewhere in the hood so that next week when you come, methylene chloride would have evaporated off, which means we don't have to do that step. Does that make sense? Is everybody okay?
So no hot water bath and no
So then, yeah, because we
evaporating.
let nature do it.
Okay.
By the way, what was after that? After you've evaporated off methylene chloride, what were we doing? We are not doing boiling point. We are not doing distillation.
We're doing boiling point.
No, we are not doing that.
Oh, we're not?
We are not. We can't. We don't have the setup. But we will do spectroscopy. So next week when you come, hopefully all your methylene chloride is gone. So then you will weigh this, you will calculate the percent yield, you will get IR, you will get proton NMR, you will get carbon NMR, and using this information, you will figure out which product it is. Figuring out which product it is will tell you which unknown was given to us. Does that make sense?
Yes.
Now I want to reiterate this. I said this in class yesterday, I'm going to say this again. Everyone should know how to use IR by now, period. And I do think everybody does, so that's great. But everybody should know how to do NMR by now without having to read that thing as you're going. That's the most inefficient way of doing lab. Watch the videos, they are all on Canvas. Everybody should know ZG, good, Control F2, good, ID, whatever it is, you gotta know those commands. Again, I'm saying this, no one should take more than 5 minutes on one proton. That's not, once it's spinning. If it's not spinning, of course, you gotta ask for help and we will do that. But if it's spinning, then it shouldn't take more than that. Also, please remember, you can do both of those together. When you have a proton spectrum with the TMS at 0, you've confirmed it, you got to start carbon on the background so you're not taking extra time. Because then by the time you're done with processing your proton, your carbon is ready to be processed and printed. So hopefully you're staggering. The other thing is, I see this often and I think about it. If a spectrum is printing, what's stopping us from taking this sample out and putting the next one? The answer is nobody is stopping us to do that. Let's find those ways to make the whole process streamlined and efficient so we are not stuck here till 5:20 p.m. In fact, my syllabus this quarter in highlighted said latest 4:30, yet I was here till 5 last week. No, I know, not okay. These labs, by the way, please think about this. These labs are designed to be done in 2.5 to 3 hours max. In fact, we used to do them. Ochem Lab used to be a 3-hour long class, not a 4-hour long class. It used to be 3 and we used to do the same experiments. Now we don't even have lab quiz. So we have even that extra time. So 4:30 latest, we got to be out. Not that we start cleaning at 4:30, no. If you haven't cleaned, I'm going to ask you to put your dirty glassware in because we are going. I'm going to lock and turn off lights and shut down everything. Latest 4:30. So I need everyone to now think about that. Sounds okay? Yes? Not later than 4:30 in this lab. Yes, Mark?
No, I'm sorry, I probably have it here, but I wanted to, is that Erlenmeyer, is that a 25?
Can be any size.
Okay.
As long as it's big enough to hold the amount of liquid you're working with.
Okay.
So that depends on how much you end up with. Yes?
In the procedure, it says, before you do the sodium bicarbonate wash,
Yes.
it says to pour your entire mixture of the 2 layers into the centrifuge tube.
Yeah.
Wouldn't that just be a necessary loss? Couldn't you just do it in the?
But you can't do extraction in a round bottom flask. That's the thing, right? I mean, the best glassware to do extraction in is something that has a tapering end. So round bottom is not the way to do extraction. So you will have to transfer into the proper glass.
And then
Just wash them, exactly. All surfaces, whenever you're transferring, make sure you're washing the previous surface with the organic solvent so you collect all. Absolutely. Anything else? Yes, please.
So we're doing IR, HMR, CMR on a product of
No. You could, but no, nobody should.
Okay.
Because then that destroys the whole industry. Come on, then you got it, you know exactly what it is. No, we are not doing spectroscopy.
we always do both.
I know you're not missing anything. It's just like if I know the spectra of this, then why even go through all of that?
Additional
stuff?
practice on the
You
NMR
know.
machine.
Right?
I don't want to do spectrum.
No, that would be the easier, quicker way of, but then easy, quick is not fun. Let's do it the funner way. Yeah, it's like me catching my nose this way, but. Oh, wow, I can't reach. Does that sound okay, everybody?
Yes.
Cool. That's the experiment. Let's go over the setup. So here's what you need. You need, could you give me one of the